So in this session, we are going to start seeing visualization. So basically here, we've created a new notebook. Let's just, and I've given it, let me see, what name did I give here? Python Lab 4, and we are going to see how to visualize data. So the first thing I'm going to do is to import the module. So we are going to import matplotlib. So we will be using matplotlib, and we will extract pyplot from matplotlib. So we are going to import matplotlib.pyplot as plt. So the convention is to give it the alias plt, and that's what we will be using. So right now, let's get some data. We want to create some synthetic data that we will use for analysis. It's pretty straightforward. So I'm going to get data for years and GDP growth. Of course, it's in percentage from 2015 to 2021. This is just dummy data. And I'll run it, Shift Enter. There we go with our data. Hopefully we have matplotlib installed, and fine. So now we want to start plotting it. The first thing we want to do, we want to run a line plot to see how this data changes across time. So I'll just put the code here. So we have a line plot. The first thing I want to do is to give the size of it. Actually, I'll plot it like this, then we'll give the size and see how it looks like. So for a line plot, you really don't need to say anything. You need to provide so you have your x-axis, it comes first, and you have the y-axis. So the x always comes first, then the y-axis, and then you give the title. So you have plt. So rather than typing matplotlib.pyplot, you simply put plt because it's the alias you gave here. So plt.plot, so you use the plot function for your line plot, and you give a title, plt.title, plt.x label for the label of the x-axis, plt.y label for the label of the y-axis, and you ask it to execute it, to show it. So I'll do Shift Enter, and we will see how it looks like. So the graph looks pretty big. We want to be able to control the size of it. So we are going to write this code, plt.figure. So inside of figure, I'll say fixed size. And this is where you'll give the height and the length of it. So you can, I'll say 8, 5, and we'll run it. So this controls the size of this figure. Okay, what you have here is controlled by that. So I'll do Shift Enter. And here I can even reduce it. So let me say, for example, 4, 4. And you can see that it's looking smaller and smaller. So I'll say 2. And I can give this maybe 8. 8 will be a bit the length, how it extends this side. Shift Enter, and that's it. So it looks much better. So you can use this to control how it looks like. However, I could also import something. I can do import. Okay, so what happens is that here I import another library which is called Seaborn. After we've worked with matplotlib, we are going to work with Seaborn to see how it is. But you can set it so that it uses some default backgrounds. You see this looks a bit nicer because of the background. However, you can still control it with all of that. It's still matplotlib, but you are using the Seaborn settings. And there we go. So that's our first chart. We are going to run the second one now. So here we want to see how to run a bar plot. We have the countries and we have the value of GDP for each of these countries. So now we decide to set the size of it. We maintain the same size we have here. And as I said, your x-axis, you'll have countries. So for a bar plot, you are looking for categorical data. So you have the countries, you have the different categories, and here you have the x-axis where you have your values, which you have here the GDP values, and here you have the title, label, and of course the Y label, and you ask it to execute it, Shift Enter, and here we go. So if you think it's too long or it's not high enough, so do some manipulation in these numbers to see how it's going to look like. So that's it. The next graph, we are going to look at the histogram. So for a histogram, you just have one set of numerical data. For example, this is unemployment of a country, and you have the unemployment across time, and you want to look at the distribution of this histogram, the distribution. So here we are simply given the size of the figure. We want to maintain it like this, and we want the number of bins. So I'll show you in a few minutes what we mean by bins. You want the bins to be 5. In other words, you want this to be split into 5 different categories. And of course, unemployment is your categorical data, and it's going to be placed in 5 bins, so 5 classes. Then you have the different labels, and of course, it's a frequency distribution. It shows the contribution of each bin to the overall 100%. So let's do some Shift Enter to see how it looks like. So here, for example, you can see 1, 2, 3, 4, 5 different bins because we chose bin as 5. You can change it and say 7, and we do Shift Enter, and here you have 7 bins. Now, I just don't want to go into some statistics because there is a formula for you to determine the optimal number of bins you need. I'm just here to show you how to graphically represent it without getting into some crazy stats. When we take the stats course for economists with Python, we are going to be seeing all of that. So here you have the frequency distribution and you have the different bins. So this class goes from 3.5 to 3.7, and here you have from that to that, and so on and so forth. You can see the different ranges. So now in the next chart, we want to take a look at a scatter plot. We want to take a look at what we generally call in economics, the Phillips curve, which is a relationship between inflation and unemployment. This is not really important because we are dealing with dummy data. This is not reality. When we go to a case study, we are going to be using data for Canada to view all of these things. But for now, let's just play with this data. We've been provided with data for inflation. You have 8 different data points, and we will be using unemployment, which has already been given here. It also has 8 data points, so we want to run a scatter plot. Now we still maintain the size. Actually, I want to adjust this. I'll make this maybe 4, and I'll also make this 4. Okay, let's do some 4, 4, and we can adjust it later. Actually, I'll do 4, 2. Okay, that's the size, and we have scatter. We want scatter plot. The x-axis is inflation, y is unemployment, title, x label, y label, and we are on show. So Shift Enter, and let's see what we have. So here we go. We have the unemployment rate and we have the inflation rate, and that's how it looks like. So if you want to increase the size of it, you have absolute control over it. You can actually come here and make it 6, and if you want, you make this 4. Shift Enter, and here we go. You have a much bigger plot to have fun with. So in this case, we want to take a look at pie chart. We have different sectors, economic sectors. We have agriculture, manufacturing, services, and construction. You have the data points, and here it's going to give us something like the relative frequency. In other words, it will give you the contribution of each sector to the total GDP distribution. So we are using a pie chart. Here we still have the size of it. Then we have PLP PLT pi. So the other one we said PLT scatter. The other one it was PLT hist. Then we had PLT bar. So you can already see that there is some sort of a pattern. You provide the type of chart you want. You have basically the GDP distribution, which is your data. That's what you have. Then the labels, you say the sectors, you have your labels there. And of course here you want, so this is simply telling you that we want the decimal places to just be 1. Okay, if you want more than 1 decimal place, you can put 2. And you have the title, then you're asking it to show, and you want it to provide the percentage should be automatically computed. So let's run it, shift enter. And here we go. So here we basically see that services as per this data, because services is 50. If you do 10 plus 10, 20 plus 30, you have 50. And this is 50. So this should have 50%, 30, 10, 10. And it's expressed in percentages. And yeah, that's just how it goes. So generally, as a rule of thumb, you don't want to have too many categories. Some say you should have 5 max, some say 7. You don't want to be having 15 categories, then no one can really see what you are trying to show here. Yeah. And in this other example, we want to take a look at a box plot. So we want to compare box plot for 2 different countries. We have the GDP growth. It was already given here. Let's take a look. We initially saw GDP growth. Let's take a look. This is GDP growth is here. So let's count it. You can clearly see that we have 1, 2, 3, 4, 5, 6, 7 data points. And when we come here, we want to use that data. This is it, and this new data. So we want to compare the GDP growth and this new GDP data provided. So you have this new list 1, 2, 3, 4, 5, 6, 7. So they are of the same length, else you get an error. 7, a list of 7, and this is the size of it. We absolutely want to plot it. We want to plot the GDP data, which is the data including these 2. Then the labels will be country 1 and country 2. And all of these are just some blah, blah, blah. So let's run it, shift, enter. And here is the box plot comparing both of them. So this is for country 1, it's that initial growth rate we had entered. And for country 2, it's the growth rate we just presented a few minutes ago. And there we go with our box plots. So this is a very interesting one. We want to take a look at a stacked bar plot. So the initial one, we just had the different sectors and we had 1 value for each of them. Okay, you may have agriculture, manufacturing, services, and you have 10, 30, 50. However, we don't just want to look at a specific situation in time. We want to look at different situations. We want to stack it to be able to compare them for 2015, 2016, 17, 18, 19. We want to compare them across years. The initial one, what we had here, it was just 1 situation. So here you had basically the bar plot, and you had the countries, and you had 1 situation. But here we want to compare them across time. That's why we don't just, well, over there we have countries, here we have different sectors, but it's across time. So we use a stacked plot. This is the size we want to give to it. And now we say bar, we want a bar plot. However, the x-axis will be years, and then we have agriculture, label agriculture. Then we have PLT bar, you have year manufacturing, bottom agriculture, label manufacturing, and here we are using a NumPy array. And in order to use a NumPy array, which we'll have the opportunity to see in a subsequent lesson, we need to import NumPy. So I'll do import. So we import numpy and we give it the alias np, and that's why we can use the alias here as np. So let me just separate this thing so that you can see clearly. So we want a bar. We always maintain years. Okay, it's always going to be by years. We start with agriculture, then we have manufacturing with agriculture always at the bottom. Then the next one, we normally have manufacturing, we have services, and the bottom we use a numpy array, which is still going to be agriculture. Then we move on to manufacturing, because here we already had manufacturing, and then we'll simply say the label, we are going to have services. Okay, in the initial one, label was manufacturing, the first one label was agriculture. Label agriculture, manufacturing, services. Then all of these are just some cosmetic things. We wanted to add the legend. The other ones we never needed a legend. Here we want a legend, and then we wanted to run it. Shift enter. And here you go. You can see what happens. You can see that 2015, you see agriculture. We precise that we want agriculture at the bottom, and it's the only one here, so it's at the bottom. The second one is manufacturing. There you go. Then finally you have agriculture. So you start with services, you start with agriculture, manufacturing, services. You can see services is top because basically it's the last one that was added here. Services, agriculture, manufacturing, services, and of course here you have your legend that has been added. In a subsequent one, we'll see how to put this legend out of our chart so that it doesn't mess things up. So we've seen a stacked bar. Now we want to see a stacked area plot. And for the area plot, it's pretty straightforward. Here we are given data. We have the years. We want to compare these different places. Asia, Europe, and Americas. We want to compare them across time using a stacked plot. And here we provide years, Asia, Europe, America, all what we have here. We provide it here. And at the level of the labels, we say these are the ones we want to be part of our labels. And of course, here we give the title year, we give the year, and here we are giving the positioning of the legend. You know, here we just let it place it there. It's the default, but in this case we are saying we want it to be at the upper left. You could put upper right, you could put outside. It's really up to you. Yeah, let's run with it. Shift enter. And there you go. So to make it much more interesting, we could make this 2, and I'll just make this 10. Shift enter, and there we go. So now we can see how things change across time, and we have that. So let's make that 4, and there you go. So in this case, now we want to take a look at a heat map, which is simply the correlation between GDP and inflation, or any two economic variables. So if you are looking at correlation, one of the ways to examine it is to use a heat map. So we are looking at both of them, but how they change across years. And this is the data, the synthetic data that has been given. We want to first of all compute correlation. So we are using numpy. This is np. Make sure you've already imported numpy dot correlation coefficient. We want it to compute the correlation coefficient between GDP growth, which has been given here, and inflation given here. It's going to compute the matrix, and now we are given the size, and when we come here, we say we want it to use the imshow in order to provide the to go and fetch the correlation matrix for what we want to show. We want the color to be cool warm. You can use another scheme, And of course, correlation, the minimum value is -1. -1 simply means there is perfect inverse correlation. In other words, when one value is going up, the other goes down. And +1 means there's perfect positive correlation. So all of them are moving in the same direction at the same time. That's just what it means. It's giving the minimum and maximum of the correlation. These are the colors, and here we say the color bar, the label has to be correlation. The range has to go from the length. So length, you are simply looking at the number of data points you have here. You have 1, 2, 3, 4, 5 data points. So it's going to give you 5, and it's going to split it by years. Same thing, basically same thing. So it's for the X tick, Y tick. And here you have your title and you ask it to show. So these are this is the real thing you want there. And the color bar, I'll just show you what the color bar is. You'll see it outside the chart once we plot it. So Shift Enter. So right here you have your color bar correlation. So that's what it is. And here it has done your computer. It's simply showing you what's happening. So across the years, you see how it looks like. It may not make much sense now, but we will have another example where we use real data and we play around with it. So in other words, whenever you see this type of color, you know you are dealing with perfect correlation. And whenever you see something like this, you know it's changing. It's just playing around. Okay, let's come and take a look at another one. We want to look at the country 1's GDP growth, country 2 GDP growth, and we want to do a violin plot. I'll just copy the size from here. And we have violin plot. We have a list where we have country 1 and country 2, and we want it to show the medians, and that's it. Everything else is just some blah blah blah. So Shift Enter, and there we go with violin plot. So we have our violin plots. It's like a box plot, but it's in the shape of violin. So when you have real data, at times it looks a lot better than what you're having right now. So that will be it for a demonstration of Matplotlib. Basically, the idea is for you to have a flavor of it. In the next video, we are going to take a look at Seaborn. And after taking a look at Seaborn, then we will start analyzing real data. We'll download data from Statistics Canada and we'll use it to continue learning. The key is learn once and learn well. Learn well once, then you don't need to come back. It's easy for me to just do some elementary things without going in depth, and then later on when you are in a real life situation, you simply find you have a lot of gaps. So it's some of the videos are long, but take your time and go slowly, but make sure you can do it. Watch the video so you do it over and over until you make sure you master it. Okay, I'll see you in the next video on Seaborn.